I recently attended the CS Ed Grad Virtual Conference, and during the final session, a more relaxed affair where students finally felt free to share some of their personality and wit, the topic of computational thinking emerged, and promptly got skewered by a very telling joke that, well, only CS Ed researchers would appreciate. But it goes like this. If you put 20 CS Ed graduates in a Zoom room together to debate computational thinking, you'd end up with 20 different definitions of computational thinking. My name is Yiping Hung. I'm a CT researcher, and this is the problem with computational thinking. It was a good joke. What made it so good was that it reflects the reality that there are many, many definitions of computational thinking out there, and it reflects real frustration in CS Ed about it. And here's a quick primer. I'm on a research project offering computational thinking professional development for K-5 educators. And we teach that computational thinking is a set of problem-solving thought processes derived from computer science that can be used by anyone in any context to understand problems, find solutions to them, and solve them. We then describe 4 separate CT components: decomposition, pattern recognition, abstraction, and algorithms. Simple, right? Except that's not all there is. That's all we tell our K-5 teachers, but there are a slew of other CT concepts that appear in literature, all nicely aggregated by fairly annual literature reviews of computational thinking. There are so many I won't even read them all. Some researchers propose or use a smaller set of CT concepts. Another group of researchers might propose another set, or another. And some researchers are so kind as to categorize the concepts so that CT research can identify common characteristics shared by groups of concepts. Thank you for the categories? That's the problem with computational thinking in a nutshell. So it isn't surprising that CT is a little bit of a joke in CS Ed. Even sadder is that CS Ed itself also isn't taken very seriously by CS departments, which historically haven't been interested in CS pedagogy. So if the originators of computational thinking aren't likely to take CT seriously, then how is it that CT research is still continuing? Luckily, there is a second stakeholder. CT has been taught to educators as a way for them to get young students exposure to computational concepts, and anecdotally, they love it. If educators do indeed love CT, then maybe CT research has a home in the field of education. This leads to many questions. Okay, maybe too many. Let's focus on a primary question. The primary question is, why do educators have a different response to CT than computer scientists do? So, what does current research say? Unsurprisingly, there's no research to confirm computer scientists' negative associations with CT. I'm guessing that might be a fairly unpopular survey to participate in. There is plenty of research on teacher preconceptions, development of CT understanding, and development of CTPD, which is a pretty sensible sequence of CT research. But there is not yet research on how teachers ultimately use and perceive CT post-intervention, and then none on how teacher understanding of CT might influence the definition of CT. Interestingly, I found a slew of recent international research on CT, the most interesting of which is the last one. It's a paper that uncovers culture as a factor of CT understanding, among principles, but close enough. It's the first identified outside factor that I've seen contributing to CT understanding. So to explore my question of popularity of CT with educators, I designed a survey to ask, well, I guess instead of asking why educators like CT so much, I needed to first confirm that they did like CT to begin with. But at the same time as confirming CT popularity with educators, I included questions that would also attempt to uncover some of the factors that might have led to that popularity. Anyways, to the results. Take them with a grain of salt. as I was only able to gather a small sample of data. But yes, overall, it appears educators like CT more than computer scientists. And educator usage of CT differs as well, but these results will be a little bit more difficult to accept as evidence since they do kind of look the same. I did kind of wonder, though, understanding between elementary educators and educators in higher ed might be significantly different. So I generated a chart of just elementary educators. Oh, and this seems more significant, or honestly, less insignificant. The CT profile of elementary educators skews heavily towards, well, what we taught them in our professional development, whereas computer scientists use a fairly large gamut of the concepts. And if we rechart elementary educator feelings about CT, well, they like CT slightly more than educators as a whole. I also did some correlation analysis across the entire dataset, and here are some of the findings. I like the 3 correlations I bolded. Those who really like CT seem to really like it as a standalone problem-solving process. Then those who use it in science seem to really think it requires computing. And then experts in CT, who typically lean heavily towards being computer scientists, seem to use it very much for generalization. There were a lot of flaws with the survey. I forgot to ask why educators like CT so much. And I guess I should have asked also why they might not like CT. And then I also forgot to include automation in the list of CT concepts. Those previous flaws on the previous slides seem easy to correct, but the ones on this list seem a little bit more difficult to find solutions to, and if you've got any ideas, let me know. So now I can ask the question, why do educators like CT better than computer scientists, since I've kind of confirmed it? And see if educators know something about computational thinking that computer scientists don't. My gut tells me that it may have to do with educator understanding of cognitive science, which computer scientists typically lack. It is called computational thinking, after all, and it would be interesting to see how cognitive science understands the thinking part of computational thinking. Well, that's it. I hope you enjoyed this presentation, and let me know if you have any comments or questions.